Have you ever looked up at the night sky, filled with countless stars, and wondered, how did all of this begin? How did our world, this beautiful blue marble we call Earth, come into existence? It's one of the biggest questions humanity has ever asked, and today we're going on an epic journey through time to uncover the story of our cosmic origins. Our story starts long before the Earth, before the Sun, even before our galaxy. It begins with a single point, smaller than an atom, yet containing all the energy and matter that would ever exist. This was about 13.8 billion years ago. Then, in an instant, the Big Bang happened. This wasn't an explosion in space. It was the expansion of space itself. Everything rushed outwards, and the universe, as we know it, was born. In the first few moments, the universe was an incredibly hot, dense soup of fundamental particles. It was a chaotic dance of quarks and electrons, too hot for even atoms to form. As the universe expanded, it cooled down. After about 380,000 years, it cooled enough for protons and electrons to combine and form the first atoms, mostly hydrogen and helium. The universe became transparent for the first time, and light could travel freely. This ancient light is something we can still detect today, known as the cosmic microwave background radiation. It's like a faint, cosmic echo of the Big Bang. For millions of years, the universe was mostly a vast, dark expanse of hydrogen and helium gas. But gravity, the silent architect of the cosmos, was patiently at work. Tiny fluctuations in the density of this gas meant some areas were slightly denser than others. Gravity started pulling these denser regions together. Over hundreds of millions of years, these clumps of gas grew larger and hotter, until the pressure and temperature at their cores became so intense that nuclear fusion ignited. The first stars were born, lighting up the darkness. These first-generation stars were giants, hundreds of times more massive than our sun. They burned through their fuel incredibly fast, living short but brilliant lives. When they died, they went out in spectacular explosions called supernova. These explosions were crucial for our existence. Inside the fiery hearts of these stars, and during their explosive deaths, heavier elements were forged. Elements like carbon, oxygen, nitrogen, and iron, the very building blocks of planets and life, were created and scattered across the cosmos. Generations of stars lived and died, each enriching the universe with more of these heavy elements. Our own corner of the universe was part of a vast, rotating cloud of gas and dust, seeded with the remnants of ancient stars. About 4.6 billion years ago, something, perhaps a nearby supernova shockwave, disturbed this cloud, causing it to collapse under its own gravity. As the cloud collapsed, it began to spin faster and faster, flattening into a disk, much like a pizza chef spinning dough. At the center of this spinning disk, most of the material gathered, becoming hotter and denser. The pressure and temperature skyrocketed until nuclear fusion began once more. Our sun, a new star, flickered into life, bathing the young solar system in its light. But what about the rest of the material in the disk? The swirling debris of dust and gas orbiting the newborn sun began to stick together. It started with tiny grains of dust clinging to each other through static electricity. These clumps grew into pebbles, then into rocks, then into kilometer-sized planetoids. This process, called accretion, was like a cosmic snowball effect. These planetesimals collided and merged, and through countless violent impacts, larger and larger bodies formed. In the inner, hotter part of the solar system, rocky materials, like iron and silicate minerals, could withstand the heat. This is where the terrestrial planets, Mercury, Venus, Earth, and Mars were born. In the outer colder regions, beyond the frost line, ices of water, methane, and ammonia could also condense, allowing the gas giants Jupiter, Saturn, Uranus, and Neptune to grow to enormous sizes, sweeping up vast amounts of hydrogen and helium gas. Our own planet, the Proto-Earth, was one of these growing rocky worlds. In its early days, it was a molten ball of rock, constantly bombarded by asteroids and comets. One of these impacts was truly monumental. A Mars-sized object, which we've named Theia, slammed into the young Earth. The collision was cataclysmic, vaporizing Theia and a large chunk of Earth's mantle, flinging a massive cloud of molten debris into orbit. Over time, this debris coalesced under its own gravity to form our constant companion, the Moon. This giant impact theory explains why the Moon's composition is so similar to Earth's crust. The impact also tilted Earth on its axis, giving us the seasons we experience today. For hundreds of millions of years, Earth remained a hostile place. Volcanoes erupted constantly, spewing gases into the atmosphere. And the late heavy bombardment continued to pepper its surface with asteroids and comets. But these comets and asteroids weren't just bringers of destruction. They were also cosmic delivery vehicles, carrying frozen water and organic molecules to our planet. As the Earth slowly cooled, this delivered water vapor, along with water vapor from volcanic outgassing, condensed and fell as rain. It rained for millions of years, filling the basins and creating the first oceans. Imagine a world spanning single ocean under a thick, cloudy sky. It was in these primordial oceans, a warm chemical soup, rich in organic compounds, and energized by lightning and underwater volcanic vents, that something truly magical happened. Somehow, through a process we are still trying to fully understand, simple organic molecules began to organize themselves into more complex structures. They formed self-replicating molecules, likely RNA at first, which could store information and catalyze reactions. These were the very first flickers of life. Over immense stretches of time, these replicators became enclosed within protective membranes, forming the first simple cells. Life had begun its tenacious journey. For billions of years, life remained simple, single-celled organisms floating in the oceans. But these tiny microbes were some, like cyanobacteria, evolved a revolutionary new process. Photosynthesis. They learned to harness the power of sunlight to create energy, and as a byproduct, they released oxygen. This was the Great Oxidation Event. Oxygen was initially toxic to most early life, but it slowly filled the atmosphere and changed our planet forever. It created the ozone layer, which shielded the surface from harmful ultraviolet radiation, allowing life to eventually venture onto land. And it paved the way for more complex, oxygen-breathing organisms to evolve. From those simple beginnings, life exploded in diversity. We see the rise of multicellular organisms, the Cambrian explosion of body plants, fish evolving legs to walk on land, the age of dinosaurs, and eventually, the emergence of mammals. And within that story, a very recent chapter is our own. After billions of years of cosmic and biological evolution, a species of primate evolved the ability to walk upright, use tools, and develop complex language. That species was us, Homo sapiens. So when we look at our world, the mountains, the oceans, the forests, and every living creature, we are looking at the product of a 13.8 billion-year-old story. We are made of stardust, forged in the hearts of long-dead stars. Our water may have been delivered by comets. Our planet was shaped by cosmic collisions, and our very existence is owed to countless fortunate events and evolutionary turns. The story of how this world was made is the story of everything. It's a tale of unimaginable scale, from the Big Bang to the first atom, from the birth of stars to the formation of our planet, and from the first spark of life to the rise of consciousness. And the most exciting part, we are the part of the universe that gets to look back and try to understand it all. The journey of discovery is far from over. Thank you so much for joining me on this incredible journey through time. If you found this as fascinating as I do, please hit that like button and subscribe for more explorations into the wonders of our universe. What part of this story blows your mind the most? Let me know in the comments below. Until next time, keep looking up.